So my name is Floris Boogaard and I'm going to talk about the need for innovations for extreme climate events. It's actually a project that has been granted a year ago and a direct result of the Cost program. So very proud of that. I did this abstract, which is in the abstract book, with Jeroen Kluk, Govert Schoof and Michael Washer, who's here in the back as well. So I want to shortly go to a short introduction on what the program is and which challenges it would face. Then show you some climate models, because that's one of the outputs of the project, and then go to some city approach, how to get measures for extreme climate events, and show you some of the toolbox, which relates to yesterday's workshop, of course, what we have been developing, and one of the websites is ClimateScan. And apparently we cannot present here without mentioning the bike, so I have a bike in my presentation as well, and of course how to get involved. So, well, shortly, maybe an introduction of myself. I'm a professor at Groningen, a lecturer as we say in the Netherlands. I'm also a consultant. I'm also involved as a co-founder for some SMEs with young professionals. And basically I have different positions to combine the worlds of entrepreneurship, education and research, because basically that's how you get things done. So I have about 4 positions involved with that, and these 4 positions have one thing in common. You're probably aware of the peculiar water management system we have in the Netherlands. If the dikes would break, I would be out of my 4 jobs. So water is quite important to me to stress. More challenges that we face, of course, except of water, is subsidence, damage to buildings, water quality issues being raised, heat stress in the urban area. So especially in the Netherlands, subsidence is a big problem. So we try to face in the INXCES project all these challenges. So the INXCES project has partners from Norway, Sweden, the Netherlands and Romania, as you can see up here, and the relevant work package for this presentation would be the innovation and tools, so models, and the dissemination. Well, there's a lot of tweets already on this project, as you could see, and please get involved. They're on Twitter, LinkedIn, ResearchGate, so there's a lot to see, and the website is up there as well. So for the modeling part, as I said, there are a lot of challenges to model. Basically, I've been focusing on flooding and heat stress, on the cases in the countries that I just named. But of course, there's a lot of modeling in the world already on the surface, and we try to link that with the subsurface in this case. So as you can see, Norway, I'll tell something more about that. Copenhagen, very interesting case as well. Of course, it's nice to go to Bangkok and Rio de Janeiro as well. But I will end with some of the cities you might not know, Leeuwarden and Groningen, where I have my professorship. And there's some cases with INSAR data that Hans de Beer, as one, is occupied with. So, to show you one of the cities you probably have been, Amsterdam. As you can see here, the modeling shows some depressions in the urban area. So to say, this is a model that calculates on LiDAR data, 9 points per square meter, how the water will flow from higher areas to depressions where the water will accumulate and cause problems. And one of the things is more and more important is calibration of the models. Those models can have rubbish in, rubbish out. So one of the things you can calibrate models with now is social media, actually Twitters. This is one example. As you can see here, there's some tweets on a tram trying to float through to this street, which is actually a very important one because it connects one point of Amsterdam to the other point of Amsterdam. And of course, fire brigades, police has to have a wide access. So that's one of the priority points that we try to solve problems from. So, and as you can see here, these are tweets on this day of a large stormwater event, 60 milliliters in an hour, that you can see actually where in the city most people tweeted about disturbance in the urban area, and you can use that. So that's one of the things that we are working on. Now the city of Groningen, you might not have been here, same model. This is the higher up, the center, and all the water flows from these streets to lower points. This is called the Gedempte Zuiderdiep. It used to be a canal and now it's a road, and as you can see the water follows the old tracks, so that can give disturbance as well. As you can see here, some videos that young professionals have gathered to show what we can do or where the problems are in the city. It's quite helpful to map. That could be considered as a tool. And if you go to Groningen, it's a beautiful city. There's one place you would want to visit as well. 7 gully paths on a row in this. I've never seen that all over the world. So there are a lot of places like this, which I will show on the climate scan later. Heat stress problems. This is a 3D visualization of heat stress. Really detailed, 4 o'clock, hottest moment of the day. No wind. You can really see the shadow of the streets in this part as well. A lot of measurements have been done on bikes, so that's a short introduction of the bike ID. As you can see here in the streets, a lot of people shopping when in the shadow, for example, and this is a big square not being used in very warm days. So we try to see the mobilization of people as well and the disturbance that heat stress has in this point. And of course, if you have floodings, you have heat stress, you can combine maps and see combined, prioritized locations detailed in the city on street level or even building level that you want to have measures in. And of course, when you make 3D visualizations with glasses and you can fly around the city, of course, there's a lot of engagement with politicians and spatial planners and other parties involved. So, because it's just a model still, it's just a tool. And the engagement starts in the master classes mostly. Master classes would be seeing measures, and some of the outcomes of yesterday would be thermal pavement or swales. What I do from the TU Delft, for example, in my PhD was flood streets, thermal pavement after 10 years and see how they work. As you can see, a lot of people would be engaged or see if it actually works and to get the message across. And of course, workshops like yesterday is a very powerful tool as well. To show one of the INXCES pilots, Bergen. Hans already mentioned some of that with some damage to buildings and these beautiful houses that have problems with the hydrology underneath. There's a good book about that. Also, 3D model, as you can see here, Google Earth based. You can visit in Google Earth yourself, going through the model and see where the floodings occur and to try to find solutions for that part, as you can see in this short visualization. And of course in Bergen, as you're probably aware, that a lot of measures have been implemented, like rainwater gardens, swales and thermal pavement, and you can visit them on a website with a lot of videos and the design of it and how they work, because monitoring is one of the pilots in this INXCES project. So, well, this is a bit of a toolbox, as you can see. This is Climate Scan, and we'll show you some more about it. These are the visualizations. This is a flooding this week in Rotterdam, actually. Some thermal pavement has been flooded to get more knowledge of that. If you have these tools, how do you apply that for another city? As an example, which is not an INXCES project, Copenhagen, as you might know, in 2011, one of the biggest stormwater events in Europe occurred. That's 150 millimeters in 2 hours. A lot of damage, as you can see in these numbers, according to billions. And mostly what has been done in the city approach is that you have detailed modeling, as you can see here. Again, the depressions, as you saw in Amsterdam and Groningen. And you have a lot of measures, swales, wetlands, water squares, and basically you map the flooding and heat stress. You go to buildings, so you can make vegetated roofs or vegetated walls. Squares could be water squares, roads could be thermal pavement, and green, you can flood parks instead of buildings, which is better without too much disturbance. And this is a climate scan. It's a web page which maps more than 1,000 projects on green and blue. So all the measures that I just mentioned. There are about 3,000 users for this that uses all around the world. It's one of the things that we use in the INXCES project. And if you go to Copenhagen, you see a lot of measures being taken after that. And you can visit it, see photos, see videos, see the documents, and learn more about it and see if you want to apply that to your city, for example. So this is one of the examples. This is the water square. Rotterdam is not the only one. As you can see here, this is just after the implementation, so you can learn a lot about it. And all the pilots from the partners from INXCES are met here as well. So the wetland in Bucharest is on here, to rainwater gardens that Tona uploaded. In Trondheim, there are about 500 locations in the Netherlands that you can visit. So there's actually a lot of information that you can derive from that. And of course, these are the case studies from INXCES. This is Bergen, this is Groningen, and next is actually Bucharest. And one of the problems that we faced is that not all the information that we need for making these models or prioritize locations to come up with solutions is available in Bucharest. And that's basically where the bike ID comes in, as you can see here. There's a wet skill in Romania, and wet skill is engaging with young professionals from different countries, multidisciplinary, in 2 weeks to come up with solutions. And one of the solutions that we have been planning is the bike ID, as you can see here, King, to come up with bikes to get to know each other, to get to know the city, but also have measurement equipment on the bikes. So heat stress is one of the things I already showed that you can measure. So sensors are being brought up. But for every challenges that you have in the city, air quality, you can measure fine dust, all this equipment, you have GPS, you have height measurements, you can put on the bike. And as the young professionals will go on the bike, they will measure actually all that data that we need. So that's a new project. It's a new pilot. If you have ideas from that, sensors or anything, it would be great if we engaged on this project to see if this could actually work. Because if not data is available, then that's a problem. And of course, I see some people looking in Romania and saying, okay, that Dutch guy with his bike, it's very hard to bike in Romania. But sometimes it is in the Netherlands as well, as you can see here. A challenge. Enough for me. I hope you see a toolbox a bit expanded from cost to this. There's a lot of to tell. Using art is one of the things that I'm very excited about, or serious gaming that we do at the Hanse University, and underwater drone sensors, and there's a lot to tell, but I will probably stop here. Maybe I can show you just
you have
for
time, you're fine.
I have time?
Yes,
Yeah?
you have time.
So maybe I can show you if this, should probably brought that up sooner, but the climate scan, which is quite filled. So if this is fast enough, probably it's not. Otherwise, I just do it during the break and show you. It's
yeah,
quite
do it during the break then. Okay,
yep.
this, I'll clap. Dermot's jumping in again.
Groningen seems an interesting choice because it's suffering from the impact of excessive gas extraction in that area. How do you extract a component of the man-made influence as opposed to the climate?
Yeah, that's a very good question actually. We experts from all the world are being shipped into Groningen, so we make quite a big people around it. There's some modeling with INSAR data, which just showed, so there's a lot of engagement with that. And there's a lot of legislation now going on to see what the problem is. We actually, there's a new Turkish professor being hired to get some international knowledge exchange on that, so that's quite interesting. And yeah, it's a very interesting case study, as you would say. Yeah, for the people that don't know it, they're earthquakes. You could call them tremors up to 3 or 4 points on the scale of Richter. And a lot of people that live there have a lot of problems with that. And the gas mining is now being reduced, actually. It's a political thing. And now we have to come up with new solutions. And one of the solutions that I'm involved is getting floating homes, which are climate resilient, of course. And Michael's working on floating homes from garbage. So having litter like plastic, making floating platforms, that's quite exciting. And 12 students are working on that. So that's one of the things, like practical things for applied science that we work on. So,
okay, cool. Yeah.
Does the use of Twitter data give you any information that you wouldn't have got anyway? Of course, you will exactly know where the thunderstorm hit. It's very concentrated, very little area of the town, but you're not able to use these Twitter data when things occur. But of course, you can use them analyzing afterwards, but
Yeah.
you could do this analysis with all other sorts of software too.
Yeah. The thing with social media in general, I showed Twitter, but of course there are more channels for that. It's about social opinion as well. So that's something that normal data would not provide. And of course the pictures, seeing how it is, so the engagement of that one. I think that's a very strong point to make on social media. But it's not exact science, of course. Calibration of model, it's more or less validation, as we would say. So it's a helpful tool, but it's not the solution to all problems, of course. So yeah, but I think it's helping, especially because social media is really getting high up. If you see, there was a great presentation about snow in Italy, for example, and you could see from satellite data that the satellite picture was not as clear enough as the social tweets about snow in the different regions, because sometimes you cannot see from satellite data where it is. But social media is very good for that. Okay, so,
Okay.
yeah.
I've got room for one more question, nobody's got it, otherwise we will move on to our last. Okay, cool. If you've got any other questions, you can ask Floris later on in the discussion.
Okay,
Thank
perfect.
you.